Suppose that the height in feet above the ground of an object t seconds after it is dropped from a height of 50 feet is given by the function h of t equals negative 16t squared plus 50. What is the instantaneous velocity of the object 4 seconds after it is dropped? I've said it before, but I'll say it again. If you learn nothing else from this class, remember that the derivative of a function is the slope of the tangent line, which is the instantaneous rate of change. This problem gives us the function for the height, so the position of the object. The rate of change in a position with respect to time is a velocity. Think about the example of a car driving a distance in miles. The rate of change is the speed of the car in miles per hour. So to handle this particular problem, if we want to know the instantaneous velocity after 4 seconds, we need to find the derivative of h of t at 4 seconds. In other words, we need h prime of 4. Until we learn the rules of derivatives, which will allow us to calculate derivatives much faster, we need to use the definition of the derivative. To avoid confusion here with the height h and our typical interval length h, I'm going to use k in place of h in the limit. So h prime of 4 equals the limit as k approaches 0 of h of 4 plus k minus h of 4 all over k. We need to find h of 4 plus k and h of 4. Notice that there's no shortcut to find h of 4 here because unlike previous problems where we were given a point to use, we just have the time t equals 4 in this problem. Replacing t with 4, h of 4 equals negative 16 times 4 squared plus 50, which equals negative 16 times 16 plus 50, so negative 256 plus 50, so negative 206. To find h of 4 plus k, I recommend starting with the formula h of t equals negative 16t squared plus 50 and replacing each t with a blank set of parentheses first, and then filling in the parentheses with 4 plus k. Doing so looks like this. H of 4 plus k equals negative 16 times 4 plus k squared plus 50. Now, to expand the 4 plus k squared, you can use a technique like FOIL, or if you're comfortable, you can use the shortcut that any binomial squared of the form a plus b squared equals a squared plus 2ab plus b squared. You may have learned about this in a previous algebra class. It would have been referred to as a perfect square trinomial. Using that strategy here, with a equals 4 and b equals k, we get that 4 plus k squared equals 4 squared plus 2 times 4 times k plus k squared, which equals 16 plus 8k plus k squared. Plugging this in, we get that h of 4 plus k equals negative 16 times 16 plus 8k plus k squared plus 50. We then have to distribute the negative 16 to get negative 256 minus 128k minus 16k squared plus 50, which simplifies to negative 16k squared minus 128k minus 206. Now we can go back to our limit. H prime of 4 is the limit as k approaches 0 of h of 4 plus k minus h of 4 over k, which equals the limit as k approaches 0 of negative 16k squared minus 128k minus 206 minus a negative 206 all over k. The negative 206 terms cancel, which is always a good sign because that lets us cancel out a k from the numerator and denominator. Without that cancellation, we end up with 0 over 0 when we let k equal 0. So h prime of 4 equals the limit as k approaches 0 of negative 16k squared minus 128k over k, which equals the limit as k approaches 0 of negative 16k minus 128 all times k divided by k, which equals the limit as k approaches 0 of negative 16k minus 128. Now that the expression is simplified as much as possible, we can plug in k equals 0 to get that h prime of 4 is negative 16 times 0 minus 128, which equals negative 128. Since the original function h of t gave the height of the object in feet after t seconds, the derivative h prime of 4, which is the instantaneous rate of change, has units of feet per second, which makes sense since a derivative of a position function with respect to time will always be a velocity. So our final answer is that the instantaneous velocity after 4 seconds is negative 128 feet per second. Note that the negative sign indicates that the object is moving downward, which makes sense for an object that was dropped.